Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When a leaving group, OTS, is displaced by an external nucleophile, acetate, CH3CO2- via SN2, inversion of configuration occurs at the carbon bearing the leaving group. However, if an internal neighboring group, here the NME2 amine, can participate first to form an aziridinium or iminium intermediate, the mechanism changes and the stereochemical outcome differs. Moving on to the next step. AS neighboring group participation, NGP, by NME2. The NME2 group on the adjacent carbon can act as an internal nucleophile. In both reactions, the nitrogen lone pair attacks the carbon-bearing OTS from the back side, internal SN2, displacing OTS and forming a strained aziridinium ion, cyclic ammonium. This step always occurs with inversion at the carbon that loses OTS. Moving on to the next step. OTS up, NME2 down, i.e. trans 1,2. In the trans isomer, OTS and NME2 are on opposite faces. For NGP, the nitrogen must attack the COTS carbon from the back face. Because NME2 is already trans, anti, to OTS, it is perfectly positioned for backside attack, forming the aziridinium ion with inversion at C1. The aziridinium is a symmetric-like intermediate. For the cyclopentane trans isomer, it is a single chiral aziridinium. External acetate then opens the aziridinium by attacking C1, the more electrophilic carbon, with inversion. Net result, two inversions at C1 is equal to retention of overall configuration at C1, giving the transacetate product as a single enantiomer, since the starting material is a single enantiomer and the aziridinium opening is regioselective at C1. And for the final step, OTS up, NME2 up, i.e. CIS 1,2. In the CIS isomer, OTS and NME2 are on the same phase. NGP still occurs. The nitrogen attacks from the back face of COTS, which is now the bottom face, forming the aziridinium with inversion at C1. However, the CIS starting material, upon forming the aziridinium, generates a meso-like or symmetrical intermediate. The two carbons of the aziridinium become equivalent in terms of substitution in the cyclopentane framework, making it an achiral or racemazable intermediate. When acetate opens this symmetric aziridinium, it can attack either carbon with equal probability, giving a racemic mixture, transacetate plus its enantiomer. Reaction 1. Trans single enantiomer of transacetate product. Reaction 2. CIS racemic mixture, transacetate plus enantiomer. This matches option A. Reaction 1 gives single enantiomer, reaction 2 gives product plus enantiomer. Why other options fail? B. Reverses the assignment of which reaction gives racemic versus single product. C. Claims both give a single product, ignoring that the CIS substrate gives a symmetric aziridinium leading to racemization. D. Shows no stereochemistry and claims single product for both, which is incorrect. Therefore, the correct answer is A. Therefore, the correct answer is option A.